This talk is called Think Outside the Chain. I think that a lot of the work that has been happening in this space has been centered around expanding out crypto to many more chains to be able to scale, and it makes a lot of sense, right? We're scaling this ecosystem out horizontally by adding more and more rollups, but this has created this problem where users have to really think in chain terms whenever they start interacting with applications. Like, how do I go to Arbitrum to use this dApp? How do I go to this ecosystem to use this dApp? Everybody's created chain tribalism, and it's very clear that that's not really making a lot of sense for new users that are coming into the ecosystems. How do you, this overarching problem of how do we actually get to the point where, you know, your mom or your grandmom can use crypto is something that's just completely intractable right now. Where do I point this? The other button. Ah, okay, cool. So to elucidate this, right, we've kind of seen over the course of the last few years that there is this like growing fragmentation. This is basically a graph of the TVL share on every chain over the course of since 2021. And you can see that over time, this is really just like accelerated, right? This is Ethereum's market share as a total percentage of TVL of the market has declined steadily, minus this little blip, which is unfortunately Terra. And now we have all of these other ecosystems that actually have very meaningful traction. And this problem is just getting worse with time, too. This is a screenshot from L2Beat. This is actually an older screenshot, so I'm sure that this number is far higher. But even in this older screenshot from like a few months ago, you can see that there's 61 live L2s today, probably more, and then 79 upcoming L2s. It's a lot of L2s. A lot of open questions around like whether we need so many L2s, and I think there's good arguments for why we do. I think that, you know, the app chain thesis is quite strong, but you can see that this problem is just getting worse and worse, right? Like as a user, how are you going to go and add 61 networks or, you know, 61 plus 79 networks to your MetaMask to find RPCs for all of them, find gas for all of them? It's kind of a ridiculous notion to expect users to do that. Now, if you've been kind of keeping track of the narrative on Twitter, you may have heard about chain abstraction. Actually, doing more audience participation here to keep everybody awake. Who here has heard of chain abstraction? Cool. Okay, a few more people. Chain abstraction is this broader notion, right? It's not necessarily a very specific technology or a very specific kind of way of doing things. It's this idea of let's remove the need for users to have to think about chains in the same way that account abstraction removes the need for users to have to think about accounts. Chain abstraction fixes this problem, right? If you have potentially hundreds or thousands of L2s, you can abstract away the chain experience from interacting of those L2s, then users can just interact with apps. This is kind of what makes app chains possible. And this is really how we use the internet today, right? When you go to YouTube today, you don't have to think about how Google's like distributed systems infrastructure works behind the scenes. You just go to the app and you search for cat videos and you get cat videos. And that's part of what has made the web so accessible starting in like the 1990s onwards. A lot of the discourse around chain abstraction is centered around intents. Now, I think intents, I always have had this a slide in there for a little bit because I think even now there's still a lot of confusion around what intents are. And so I like to kind of point to an intent protocol that everybody is very familiar with, which is Uber. And Uber is an intent protocol, right? It's basically a fairly simple marketplace. You say, I want to get from point A to point B. I want to get to like Fort Canning Hotel. You put that into Uber, and Uber sort of implicitly assumes that you want to do that as quickly and as cheaply as possible. It broadcasts that out to a whole network of drivers that are looking to basically fill that intent to get you from point A to point B, and matches you with the best rider for that for getting there. And then at the end, of course, you settle with the driver, and Uber takes a fee. This is really also how like other intent protocols work. So you can kind of imagine like a chain abstracted flow where like I'm living on Arbitrum and I want to go and interact with Aave on Aave chain when they actually move there. How would an intent protocol like a cross make that happen? Well, you as a user would say, I want to get to Aave chain. I want to go and lend on Aave chain with like 1,000 USDC. Across would broadcast this out to Across's solvers. One of the Across solvers would say, hey, I actually have the money to do this, and I can do it extremely cheaply. They will go and fill the money. They will basically go and fill that transaction. They'll lend for you on Aave chain. And you, as the user, at that point, your transaction is done, right? It's, that kind of takes like seconds, if that. And it costs almost nothing. Over time, we're sort of seeing that this pattern is percolating into kind of a stack, right? This is a stack that is being built around this concept of intents. And there's an ecosystem that's emerging around it, which is really fantastic. That basically means that there's a broad coalition of different projects that are working towards achieving this outcome. And you can see that they're sort of like, you can almost kind of map directly the like relationship between these different steps of like, hey, I'm going to request that something happens. That request is going to get matched. We're going to find somebody to actually fill that request, and then that's going to get settled. You can map that pretty much directly to these different steps, right? At the permission layer in the wallet, you're saying, I want to go and make this transaction to Aave chain. You go and interact with something like a cross, which is an auction, to auction that off. A solver goes and fills it, and then it gets settled with the chain. So why does or doesn't this work? Or why hasn't this actually taken off as much as we want it to? Well, there's still a little bit of a dirty secret, which is that solving isn't really profitable today. There's a lot of like solvers, everybody kind of talking about intent solvers, everybody's talking about intent-based protocols, but nobody's really running solvers except for the like the intent protocol teams themselves, aside from a few fairly specialized solvers that are run by folks like Wintermute and like other people with lots and lots of money who are definitely just like absolutely dominating the market right now. And this is really interesting, right? This is not exactly the decentralized world that we want to build, because today, if you're trying to solve for these ecosystems, you're up against these like very, very big sophisticated players who are winning the vast majority of the order flow. And if you, the scrub that you are, actually goes and tries to run a solver, you're not very likely to make any money. And there's a reason for this. And the simple reason is that if you're kind of going through this like intent flow that we talked about earlier, right? You have again, user tries to deposit to Aave chain. You as the solver go and fill that transaction on Aave chain, and then you settle back into the user funds. What you'll notice here is that in order to settle, what's happening is you're getting the user funds back on the source chain, because that's where the user paid you, right? So another way to think about this is your liquidity, you're paying on Aave chain, and you're getting repaid on Arbitrum. Now imagine if this wasn't Arbitrum. Imagine if the user was coming from degen chain or from some other long tail L3 that nobody actually wants to get to, right? You as the solver, your funds have moved to a place where you now need to think about rebalancing. You need to figure out how to get your funds back to Aave chain so you can continue filling transactions for users that want to use Aave's application. So how do you rebalance? This is actually the really difficult part about chain abstraction. This is the reason why large-scale market makers like Wintermute are doing this so much better than any other indie solver can do today. Because rebalancing requires going through bridges. You haven't actually gotten rid of the bridging problem. You've just given the exact same problem over to a solver that now has to do it. So who is able to do this very effectively? Someone who has hundreds of millions of dollars in capital and has an entire operational team that is very used to rebalancing money between chains. And this is the really interesting part about fragmentation. It's like you can't really like get rid of it. Fragmentation exists in this space. It exists because inherently it's a part of the way that the ERC20 token standard is designed. There's no mint and burn within the token standard itself. We didn't build tokens with the mental model that there would be many chains. And because we didn't do that, because we didn't build bridges with the mental model that would, or at least like canonical bridges for rollups with the mental model that there would be many bridges, we have this ecosystem where liquidity just goes and gets locked in a bunch of different places. And so no matter what you do, you can go and you can build a bridge, you can go and build an intent protocol, you can go and continue to push this problem out to different people, but ultimately someone has to pay this price. And so who pays this price today? Well, you go and you talk to the intent solvers and you say, hey, how do you rebalance? They say, we actually work with a market maker to do this. You go and you talk to the market makers, they say, how do you rebalance? And they say, well, we use the centralized exchanges. And you go and you talk to the centralized exchanges and you ask them how they rebalance, and they say, we're hiring a team of people, and they just go and sit on the Arbitrum UI and they just press the button once a week or something like that to go and move hundreds of millions of dollars of capital through the canonical bridge, which is insane. They're locking up hundreds of millions of dollars for like 7 days at a time. Here's the kind of key insight between what we're doing with Everclear. This is obviously like a really big problem and something that we've been thinking about for a very long time. A bit of a history lesson before I jump into this. So Everclear, formerly known as Connects, was actually one of the first intent-based protocols. We were really fortunate back in like 2020, 2021 to start thinking about this interoperability problem. And we were also very fortunate that like the stuff we were working on before, which was building one of the first kind of L2s in the space, was centered around intents. We didn't really realize that at the time. The intents terminology didn't even exist until like a year and a half or 2 years ago. But we realized, and we ourselves in 2021 started to run into this problem, where we realized our own solvers were having to rebalance. And what we realized was that out of like, $50 million of TVL that we had in the protocol, maybe about like 2.5-ish million was actually being used. The rest was just sort of sitting around. And it was sitting around because our solvers just didn't know how to rebalance effectively. Over time, and over the course of the last few years, after thinking a lot about this problem, we've kind of come to this very, very interesting realization, which is, why are we even rebalancing in the first place? Right? When you actually track the global flow of funds between chains, 80% of it nets out, which basically means for every like dollar that is going into Arbitrum, 80 cents is coming out. Or in this case, actually, more specifically, where is Arbitrum here? Okay, so Arbitrum is 60.5. If you look at something like BNB chain, for instance, right? Every dollar that goes into BNB chain, 85 cents come out in the same time period. And this is just public flows, by the way. This is just like us looking at DeFi Llama to figure out how much is moving through the canonical bridges. This doesn't include centralized exchanges, doesn't include OTCs, which is really where the vast majority of the volume exists today. So this begs the question, why actually send all of that money, right? You have these flows of funds that are moving between chains. Right now, what we're doing is when you have these flows of funds moving between chains, people are rebalancing. This is $420 worth of funds. When in practice, within the same time period, the actual delta, the final movement of funds was only $10. Why do that? Like, why are we paying to do that? And this is a really interesting open question, right? Like, this is actually something that's fundamental to financial systems even outside of crypto. When you have like Visa, for instance, or the New York Stock Exchange, one of the core functions that Visa and the New York Stock Exchange do, they're clearing houses, and one of the core things that they do is that they basically aggregate all of the transactions that are happening on top of, like basically for stock trading or like payments as part of card payments, and they turn them down into, like net them down into one final sum that is transferred between banks, or that's transferred between financial service providers. And this is part of where efficiency comes from in capital systems. And so what we realized was that this space needs something like that. We need a system that performs the same role. And Everclear is that system. Everclear is the first clearing layer. Not a clearinghouse, because clearinghouses are central entities. Instead of being a central counterparty to every single trade that is custodial, Everclear is a roll-up. It's a system that allows for different market actors to coordinate with one another to actually figure out what is the optimal way to move capital between chains. So rather than, for instance, you are a solver or a market maker or somebody like that, or even a centralized exchange that has funds on Polygon, rather than having to rebalance those funds to Arbitrum yourself by going through the canonical bridges, by taking the 7-day lockup, potentially for like millions and millions of dollars of funds, you can just express on Everclear, I have funds here and I want to get over here. And Everclear sort of finds that coincidence of wants. It looks for anybody else, any other market participant that has funds and wants to go in the opposite direction, or really wants to go anywhere else, and allows you to kind of atomic swap with them. You can almost think of it like a very slow cow swap. So cow swap does this same process. It finds coincidences of wants, but cow swap does that as part of trade execution. So if you're a trader, you submit your transaction, and then cow swap takes like a few minutes, and it tries to find other traders within that time period that you can net out with, that you can find cows with. But of course, because it's only a few minutes, you don't really find a ton of cows. Whereas in Everclear's case, right, this is a back-end system. It's for, again, centralized exchanges, for solvers, people who are fine with waiting like a couple of hours if it's going to give them the best possible price, right? Because we're talking here about like fractions of a percent. We're talking about like on the order of ideally less than 1 basis point. And so if you are a market maker rebalancing $100 million, 1 basis point is, fantastic. Half a basis point is even better. You're still saving a lot of money. I think we are in this really interesting place in this ecosystem right now, where we've kind of tried to continually solve fragmentation by like building more and more stuff, and in a way that has actually just made fragmentation a lot worse. So like everybody goes, the solutions that have existed so far are like, oh, okay, there's a lot of bridges out there, and we've like fragmented liquidity across the entire space. Okay, I'm going to go and build a bridge, and I'm also going to go and bootstrap my own liquidity in my bridge, and my bridge is going to be more efficient than everybody else's. And then that's just like made this problem worse and worse for everyone. And so rather than just trying to build another bridge, what Everclear does is something slightly different. It allows for existing bridges and existing market makers to coordinate with each other, right? Everclear does not have TVL at all. It's not a liquidity-based system. It's just a coordination mechanism. So bridges can work with each other to be able to find optimal solutions. It makes everybody's lives better, and it's a good example of the exact kind of like neutral public good that blockchains are actually good for, right? And this is one of the few things that I think we've sort of few instances we've seen in the space where we're like, wow, yeah, this is actually a shared public resource. How does it work? I mentioned earlier that Everclear is a rollup. Effectively, it's kind of a neutral computer that sits in the middle of like any chains. Whenever you have solvers, intent projects, anybody that wants to move capital between chains that want to actually net out with other solvers, they deposit funds into gateways that sit on every chain. These are just like simple contracts that are just holding funds and holding them for everybody that is using the system. The Everclear rollup reads how many funds are available on each gateway at like periodically. It's once every like 15 minutes or so. We do this using Hyperlane. And then all of those funds, or all of the kind of basically pending settlements, get pushed into a queue of what we call invoices. And then the system just tries to find coincidences of wants between the invoices. Anything that's left over, so for instance, say there's like, as we said in the earlier example, 80 cents of value that is flowing into Arbitrum. Anything that is left over, the remaining 20 cents, basically gets auctioned off in a Dutch auction. And so you kind of have this like really awesome guarantee where it's like, you know that you're going to get the best possible price because you know that you're going to net out as much as possible before people are going to, before your funds, your invoice starts being sold. And then there's now this really awesome incentive for any arbitrager, for any remaining capital to come and fill these transactions using existing bridges. I'll leave some time for questions in case people have questions on that. I know it's a little bit complicated. Everclear sits at the bottom of the chain abstraction stack that we talked about earlier. And it kind of creates this like abstraction layer between settlement, which is this like more complex process of interacting with transport protocols like Hyperlane, Layer 0, things like that, the chains themselves, the centralized exchanges, things like that, and the rest of the stack, right? For solvers and other people to not have to think about, hey, I need to go and integrate this canonical bridge. I need to go and integrate LeFi. I need to go and integrate all these centralized exchanges. Instead, they can basically just work with Everclear that abstracts all of this away, makes the process as simple as possible for them, and allows for solving to basically be able to be done by anybody. Right? Rather than having to be a Wintermute specific thing, solving now becomes a process, and this is really like the key goal for us, becomes a process that people can do from home. Right? And that is the kind of decentralization we want to achieve. We want to take that like very intense power law curve that we saw earlier, which is what solving looks like today, and ideally make it into a straight line, right? If you should ideally be always earning fee revenue proportional to the amount of liquidity you provide, rather than exponentially proportional, like what exists today with something like Wintermute. We're in the middle of this really interesting transition in the space, and this is just a bit of an aside, but we've obviously seen so far that there's this like shift from this. I swear there's a laser pointer here somewhere. Oh, there it is. Okay. Oh my God. Okay. Anyway, we're in the middle of this really interesting shift where we've already kind of made this transition from seeing these large-scale monolithic blockchains like Ethereum used to be, right, over to the modular thesis. The idea behind the modular thesis is you can separate out these components, you can allow people to specialize on them, and then users, in this case roll-up operators, can mix and match whatever components they think are best. And now in doing this, we've kind of created fragmentation, right? And now we're working to fix that. And so we're in this process of moving towards these abstraction layers that sit on top of the modular thesis that basically allowed for us to tie this whole ecosystem together. And then this looks a lot like how the internet was actually developed between like 1970 to 1990. Right? There was initially just like one single mono network that everybody was living on. It was really large-scale computers run by universities, to this like broader network with like the ARPANET that was run by the U.S. government and like a bunch of other people. And at the time, if you were using the internet before 1990, it was like a bit of a shit show. You had to like manually connect to different networks in order to go and retrieve files, very similarly to how you have to manually connect to different networks to use apps today in this space. And then in the 1990s, we created HTTP. And that was when the web became available, right? We went from, I have to be a software developer that is going and using command prompt to connect to networks, to I can just open a browser and type in a URL, and it's just going to serve me information. That's the transition that we are currently working on. And that's kind of the core of the chain abstraction thesis and what clearing enables. Cool. this is actually a little bit of leftover from last time I gave this talk, but yeah, this process is known as the modular mullet. So if you don't know the modular mullet, mullets are now back in style. You should grow one. We're really, really close to getting to a point where we can actually go and build a lot of the really interesting things that we've wanted to build on top of blockchains for a very long time. When I got into the space, I was not, don't get me wrong, I like solving these really hard problems around scalability, but I didn't get into blockchains because I was like, I want to fix blockchain scalability. I got into building on blockchains because I was like, I want to build really, really interesting public goods. I want to build cool shit that fixes the world, right? I want to build tools that help people resist authoritarian governments. We are now on the cusp of actually that becoming possible. And this, I think that we're kind of like in this final shift. It feels like there's a lot of market fatigue associated with just constant narratives, constant push to be like, this is the new thing. But we are so close to getting to the point where you can actually build usable stuff. And I think that that's maybe the most exciting thing that I've experienced for a while now after being in this space for almost 10 years. And that's it. Yeah, thank you all for learning a little bit about Everclear. I don't know if I have time for questions. Okay, cool. If anyone has questions.
So how many clearing protocols like Everclear exist currently in the market?
0 other protocols. Yeah, we are the only ones. There are other people that are kind of performing a similar role, but like I said, they're performing that role. So basically, like, who is the biggest competitor to this right now is basically Binance. Like, Binance is doing this effectively themselves, but in a totally centralized way using their own capital. And I think they and other exchanges that are doing this are like either charging for it and charging other institutional providers, or, and they're doing this using sort of like B2B deals, or they're not charging for it and they're losing money on it. So we've talked to a bunch of centralized exchanges about it who are like, yeah, actually we didn't realize that this was what our infrastructure is being used for, because most exchanges don't like charge for depositing on one chain and withdrawing for another. But there are like market makers that are arbitraging this right now by like going and charging 5 to 10 bips as a solver on something like a cross, and then on the back end going and rebalancing on like Kraken for 0, which is crazy. Yeah.
So what is the fundamental difference between Bridge and Everclear?
Bridges have TVL. Everclear doesn't. So like a bridge, or I guess we're sort of seeing this like shift away from, like, the term bridge is obviously like super overloaded, right? It means a lot of different things at this point. We're seeing this kind of shift away from like, we just have large pools of liquidity everywhere towards intent-based bridging because it's just more efficient. You don't have to like achieve consensus and things like that. There's just a lot more complexity involved with like pools. But with intent-based bridging, you have a solver, some service provider that's holding liquidity. Whereas with Everclear, there's not really any service providers at all. There's no solvers or anything like that. It's just allowing for those solvers that are holding liquidity to work together to optimize how they manage the liquidity. Any other questions?
All right, then big round of applause for Arjun. Fantastic talk.
Cool. Thanks, everybody. Oh, I guess one last point. So if you're interested in chain abstraction and in all of this, there is actually an event happening on Thursday called Abstract that you should check out. There's a lot of really fantastic talks happening from people that will also be here at this event that are going to dive into a lot of these topics. So